time for another coding session. All right. And of course, we're continuing with Bangalang. At the end of the last session, we rearranged this to-do list. So it's kind of arranged from highest to lowest priority. Highest priority is bugs and issues that I want to clean up, make the language, all the features that we have, I want to solidify them because, honestly, I just kind of bashed them out and didn't really test a lot of things properly. And so just making what we have solid is the main priority. Then I have like these core features, which to be honest, I'm not even sure how core I feel that they are. But at the moment, those are the kind of things that I would like to have before I start actually using the language for other projects. Some dev tools that I want to implement. All these are all nice to have features, so I don't feel like they're essential to do right now. And then these questions are like things that I'm not sure if I'm going to do or not, whether they make sense in our language or not. So really, bugs, issues is what we want to tackle right now. It's the biggest list, actually, I think, but it's not huge. It's, I don't know how many lines that is, 27, so I guess it's 25 lines. The one that I wanted to kind of tackle right now is stack variable import uses wrong address. So that issue is where, like, if we go into our playground, see if strings had a stack variable. So if I go into core strings, and at the moment it just exports a whole bunch of procedures. I think that's it. Let's say it had foo, which was a u8 42. So this is a stack-based variable. So if I tried to import strings.foo like this and make my own variable based on it, the address that gets used here in the assembly is wrong. And I'm not really sure how you would correct it. I'm sure it's probably possible, but difficult and not something I really want to tackle. And actually, something I've been thinking about for a while now is whether to use a main procedure or not. Like right now, see this playground, it's just, the code is just, it's kind of like Python or JavaScript, or I guess generally scripting languages, you can just do this. You just write the code straight here. You don't need a main procedure. I'm thinking I want to add a main procedure. And then I also want to restrict what happens outside of a main procedure so that we can't have stack-based variables at the module level. Yeah, and that would get rid of that problem. It also has the benefit of, because I want to make it so that all you can do at the module level is basically declare variables, and those variables cannot be stack-based or memory-based. When I say memory-based, I mean, like dynamic memory. So it basically means they have to be either stack or not stack, static variables or procedure definitions, that kind of thing. Yeah, I think that's a good restriction to have, because then when you import a procedure or import a module, there's not going to be this side effect code that could potentially get run. So the only way that code is going to get run is if you call it. So I like that kind of guarantee that there's not this side effect of like just code gets run without you realizing. I think that's nice. Anyway, so that's my idea. So we would end up with main proc equals something like this. And we put all the code in there and indent it properly, like so. So this is what this file would turn into. So we need to make a few changes here. because right now this main procedure is not going to get called. I guess if we run the playground, it's probably going to run, yeah, but it just doesn't do anything. It never calls main. So I guess the two things we need to do is restrict what happens at the top level, and also make sure we call main. Let's call main first. I feel like that's the bigger thing to do. Or not that it's more difficult, but the more important thing to do is that we actually call main. So something that I've been thinking could be really nice. I've got this load module. I think we could use this in other places too. So this basically performs tokenization and parsing. And I want to extract that part out so that I could just load any code. It doesn't need to be a whole module. I could just load any code and get the AST for it. I think that's just generally a really nice feature to have in the compiler. Because there's a bunch of places in the compiler where I basically hand roll my own AST. I programmatically create the AST from scratch, which kind of sucks. It would be much nicer if I could just specify some code and then, so is that all we need is the code? Yeah, if I could just specify some code and then get the compiler to generate AST for it. So this here is, it's not going to load a module that already exists. That's not a thing here. We don't have a readable name. I guess we need a name to give it. Because the tokenizer will append, it'll sort of annotate all the nodes with that name, so we know where the source came from. This stuff down the bottom here is also to do with like module stuff. So it's basically this part that we want. But we want to return kind of like this one returns, yeah. We want to return all this stuff. We need to return the nodes, which means we have to change the name of this. Like so. So that returns that. Parse module. Is this the only place that it's used? Yeah, it's used twice in this file, but then actually we can just do load code now. So it would be load code with the readable name and the code. And I think we can just all return. Oh, but we need the statements like so. Yeah, so now parse module is only actually called here. And it doesn't really make sense to call it parse module. And to be fair, in type checking, we don't have like a type check module, and I don't think we have like a generate module either. Yeah, I don't see that. So I think it's kind of nice actually to not have this parse module and just instead yeah, we already import parsing, so we'll just do that instead of parse module, I think. So if parse statement ever fails, and that should be parsing.parse statement. Okay, interesting. Yeah, we just do it like that in here. Because these return types, when you have, or these return these multiple returns, when you give them names, you can actually use them like variables within the file. So we can just do this. For some reason, it's not liking that stream. I guess it needs to be at stream. Did it not to be that here? Oh, it got passed in. Okay. So we have a context and a stream. We do all this. We parse all the statements. If we ever come across a statement that's not okay, we print the error and return false. Otherwise, we keep going. I think that's about it. So then this module file, let's get rid of that. And now we have a way of just tokenizing, parsing any code. The code needs to be one or more statements, but I think that's a fair restriction. So the reason we did that was because in main, so in main, I want to type check I think before we type check all of the procedures, so I think I'm going to extract this part. So instead of type check program, which actually doesn't really make sense for the globals, we're going to load the globals path. Yeah, we're going to load the globals. I feel like globals, yeah, we have this core globals path, which is not used anywhere. Maybe we can put it in the AST types. This core globals path. So we don't need this one really. We can go ast.core globals path. We need to import loading, it looks like. Go to the top. Oops, I've got my wrong keyboard layout. Like so. So the globals module is something that we import up front. And we can't all return here. We need to have this kind of structure. So if something goes wrong, we just exit with code 1. Then we create our type checking context, which needs to use the core globals path. So we need type checking dot. That also needs to be like that. Oh, I did that wrong. Oh, no, I didn't. It's just that should be, yeah, no, I did that wrong. Should be like that. There we go. Okay, so that needs to be at, and that needs to be the core globals path. And then we want to type check the statements that were in the core globals. So that should be fine, except instead of the or return, we, like up here, we need to do the same pattern. If it fails, then we exit. So that replaces this type check program call. So we load the globals module, we create a type checking context, then we type check the globals that we just loaded. So the globals module is, it's the scope. You know, we've already grabbed it, so no need to grab it again. This is the import declaration. I just feel like that's a bit better. That's actually something I wanted to change. This is just a random aside. But in here, when we get in the declaration, this identifier node think it's clearer to call that the declaration. That's what we're trying to get. What we get out of the identifiers is the declaration. I think it's also here. That seems nicer to me. Okay. And that's the globalist module. So then we apply the everything from the globalist module to the program identifiers so that they become global. And now I want to do the same thing with the entry module, which is what you specify in the command line as your main module. So now we're going to do this with the path, and I think it's just called code. So we load that module. Again, we'll just update instead of doing this, we'll just update the existing type checking context. So the scope uses this path. And then we type check that scope, which is the main module, and then the other thing that happened in here. So basically we've taken, I think this is only called, it's not called anywhere now. So this part we've taken care of. It's basically just type checking the queue, and also is doing cyclic import checks at the end, just a random place for it. I actually wonder if all you can do is static declarations and procedure declarations, does it even make sense? Like, do you care about cyclic imports? I guess you could declare a static variable and then you could assign to it some other value in two different modules, and the order in which that happens could matter. But maybe we can just restrict it so that it has to be a declaration. So only declarations can happen at the top level of a module, and they cannot be stack or dynamic memory allocations. I think then cyclic imports don't matter. Let's get rid of it. I mean, it's in source control, so if we need it, we can grab it later. But I think it doesn't matter with this. So this is more like type check queue now. I don't think it uses those. So this is going through the queue of procedures, which I guess would make sense to put here as well. It's going through the queue of procedures that we build, which is basically all the procedures that are referenced in the program, and it performs type checking on them. All right. So let's rename that file to queue. And then in the main, we need to type check the queue. After we have type checked the entry module, then we type check the queue. Now, currently, nothing is going to be on the queue. If we look at this, see there's a procedure declaration. All these imports just have procedure declarations as well. So, but nothing ever gets called. And that's where this load code thing comes in. So I guess I would need to go maybe up here somewhere before we type check the statements in the main module. I'm going to do load code, and the name, I guess the name would be just this name. So it's the name of the main module. And the code is going to be just call main. Now, depending on this, like if this file ended, like if it ended with blah u8, and then we just appended that code, wouldn't it go like this? And then, oh no, because we're parsing it separately, it's totally fine. Yeah, it's getting the AST is just for the AST for this. So we just want to append this to the end of the main module. We just need to call main. So this should return, what does that return? Call main and call main okay. And we're going to have to do something like this. So if not call main okay, then we bail out. And I guess we say something like failed to load call main. Call to main. That's in the wrong place. There. And now we're going to add to the scope. The scope has all the statements that were loaded here. And now we just want to add, this is just a single statement, right? So we just want to add that statement to the end. So if we get the statements and we append call main 0, that one statement. So now it has this statement on the end. So then when we go into type checking and everything, it should call it. So if I run that, yeah, now it's done what we expect. It has called main. Perfect. Okay, pretty happy with that. So now we need to do some of these restrictions. So we need to restrict the allocators that are used at the top level, and also the type of statement. I said that they need to be declarations. Okay, great. So first let's restrict the allocators that are used. So I think that would be in the left-hand side of the expression, or left-hand side expression of an assignment. We type check the allocator. This is where we apply a default allocator. And at the moment we default to a stack allocator for anything that's not a procedure. But at the top level, because that's not a valid allocator, I think we should default to the static allocator. Just to make this a bit simpler, I'm going to say procedure type. So if it's a procedure type, we default to the code allocator. Otherwise, we check the length of the current path, and if it's 2, that means we're looking at a module. Which means that we want to use static. Because I'm not sure of the order of execution there. I mean, I'm pretty sure you don't need the brackets, but anyway, that makes it clear that if it's a procedure type, then it's code. Otherwise, we do this additional ternary. Good old nested ternaries. So now it should default to static. And then in here, we are checking if the allocator is an identifier that's not a member. And then we're making sure it's one of the core allocators. Okay. So we wanted to restrict, so out of the core allocators, actually all of these are fine except for stack when we're at the top level. So in here, I think I'll just say if we're at the top level and we've been given the stack allocator, then that's no good. So, oh, this must have been some debugging. Let's cut that out. So let's say cannot apply a stack allocator to a module level value. Okay, and then down here, so this was returning true if it found one of the built-in allocators. So now we type check the allocator, and then we make sure that it is either a code or memory allocator, because those are the only kind of custom allocators you can have. And if it's not one of those, then it's no good. This is something that we missed when we were doing the kernels in the last session. Because we did all these restrictions to kernels, but we didn't restrict that only kernels can have custom code allocators, which I think we need to restrict. So a regular procedure is it's always just the built-in code allocator, which would be, for the whatever assembly we're compiling to. It's only kernels that can get called on the GPU, so only they can have these custom code allocators. So let's add a condition for that. Let's say if it's a code allocator, well, I guess if it is not a kernel type, actually, is that another check we need to do? Like for the the built-in code allocator, should only be able to apply to procedures. I don't think we have that restriction. You shouldn't be able to put a code allocator onto, an unsigned int. That doesn't make any sense. So maybe we'll put this here also. It doesn't matter where it happens. Well, if it's a code allocator, if it's not a procedure type, and we're trying to use a code allocator, this needs to go up here. If it's not a procedure type and we try to use the code allocator, then we say cannot apply a code allocator, or let's say the code allocator or maybe we'll take the same structure. I like consistency in my messages. That's why I'm like fumbling with this. So cannot apply a code allocator to, let's just put the type in here. So to type name, what is it? Node.data type, I guess. Yeah, cannot apply a code allocator to that because it's not something like that. And down here, we're even more restrictive with the custom code allocator. If it's not kernel type, we say cannot apply a custom code allocator or maybe here we'll structure it a bit differently. So we'll say custom code allocators must be applied to kernels or can only be applied to kernels. I like that message. So let's just try that, so if I say blah u8 at code, that should fail now. Oh, globals cannot apply a stack allocator to a module level value. And that's happening in globals 9, 10, 11. It's probably these parameters because they, by default, get a stack allocator. Well, no, they have to have a stack allocator. That's the only way you can allocate parameters. So maybe I need to say, and if we're looking at a procedure type, then we don't apply this restriction. Yeah, cannot apply a code allocator to type U8. Sounds great. So if I say compute shader, so that's a custom code allocator. I need to import GL from vendor. Custom code allocators can only be applied to kernels. So even if I say this is a procedure, still says that. Okay. And if I say it's a kernel, it's probably going to say kernels must have 2 parameters. Yeah. So I need to do index u32 and then some sort of slice. Blah has already been declared, but more troubling, there's an error. So first I'll just check, oh, it allowed that. Because it's allowed for kernels, of course. But the more troubling thing was that that was an error. To byte size, the type node is none. So we're generating a procedure. What procedure is it? If I go to context output, can I see? No, the buffer's not going to show me all the data. So if I go to the assignment left-hand side node is blah. Yeah, so it's this line. Okay, interesting. Probably because well, wait a minute. Why is it going to if there was an error? If there was an error, then it should not go to generation. There was an error in type checking, so it shouldn't go to generation. So what's happened? I think I've missed an or return somewhere. So let's check. This is returning false. So we come up to here. See, this says or return. So we come up to here. These return, so that's good. So that should be failure, type check statements, type check Q. Ah, here it is. This is the very top. Okay. So if that fails, we should go like that. Okay, blah has already been declared, exit code 1, but there's no, the compiler doesn't crash. That's nice. We have a lot of files open. So we don't need this. Okay, so now I've gone and closed where I was here, I think. Yeah, this is where we're doing our allocator restrictions. So next thing is I should not be able to say that I want to use a stack variable here. Yep, can I apply a stack allocator to a module level value? And os.heap, we're already importing OS, so this should also be invalid, but it's not. I think I haven't actually added that check yet. Yeah, so if it's a memory allocator, if we're using a custom memory allocator and we are at the module level, then we have an error message like this. Cannot apply a memory allocator to a module level value. Okay, so I'm happy with that. Now I want to restrict so that only declarations can happen at the top level. So I think we can do that in statements. Yeah. So if the length of the current path equals 2, so if we're at the module level, and statement.type is not assignment statement, not assignment statement, and I want it to be declarations only, right? Not just it's not that it has to be assignment. So if it's not an assignment, or the left-hand side data type is nil, even though we haven't type checked the statement yet, declarations should all have a data type. Some of them will be the none data type, but they should all have one. So the absence of a data type here means that it's an assignment. So we can have like bop equals 42. So here, this is going to have the none data type. But if we say bop2, now if I say bop equals 43, so here bop before type checking is not going to have any data type. This is a declaration. This is an assignment of an existing variable. So then we want to put an error here. If we go back to where we were, I want to get one of these top level value. So then we say How do we structure these? Cannot do this to a top level value. Let's just say module level statements must be declarations. Something like that. Actually, that's kind of a module level statement must be a declaration. So that's line 5. See, so that line failed. This line succeeded, which is great. It's inferring the type, which I mentioned this in a previous video. I'm not sure about that. It would have it would default to I64, and then it's, because I haven't specified an allocator, it's using the static allocator, so that's all good. But this is not. Pretty sure I changed that. Huh? What? One, line 1, 5. Ah, okay. I was interpreting that as line 5. Oh, so that one is line 5. But now it's line 1. So I think what that is, because when we did our main stuff, changes, remember we added this thing here. So this AST that it produces is going to call this line 1 because it is line 1 of the code that just got loaded. And we use the same name, so it's examples playground. So actually, if I used this, if I said load main, I'm pretty sure this is going to say, yeah, load main. So that makes sense because this is a right-hand side expression. It's not an assignment. It's not a declaration. But this is an exception. This should be allowed. So, but it should only be allowed at the end of the entry module. So I think we need to add some extra context here within entry module. We've got a lot of these withins now. Within entry module. And I think this will only exist while we're doing the top level statements of the entry module. Yeah, because when we do the queue, we create a new context for each one. And I mean, I guess technically when you go into procedures within the entry module, maybe that context should still be set, but I don't really care right now. Having this at the top level is enough for now. Yeah, so I guess, and not, so, and I wanted it to be the last statement, so we need to get the index. So if it's not, so I guess here we need to verify that it is a statement. Oh no, it's not an assignment statement. It's a call. So the case where it's a call, and it's not a member, well, the first the child of the call, which was the thing that's getting called, the procedure that's getting called should not be a member, and the thing that's getting called should be called main. So in the case that we are calling something which is not a member and which is called main, and it's the last statement. So if index equals length of statements -1, so if it's the last statement, it's a call, and it's a call to the non-member main, that's okay. So that's why all of this whole condition, we put a not in front of it. So that should allow the main call. Yeah, okay. That's happy. Cool, we can cut that out. Let's try OpenGL. Okay, seems like there's a non-declaration in GL. The link. So link should be allowed at the top level. It's not actually a procedure. So should we allow things that have the allocator of none? No, because some of those do generate assembly. I think it's more just that link and import. I'm not sure why import didn't trigger it, but link and import should also be exempt. This condition is getting massive. Let's at least break it up into separate lines. Is it going to allow me to have this on multiple lines like this? Okay, yeah, that's happy with it. So in this case, it doesn't need to be the last statement, but if it's a call that's not a member and it is one of import, or if it's an import or link, looks like I have to explicitly put that. Yeah, so calls to import or link are fine. OpenGL 10. Oh, sorry, OpenGL 10, not GL 10. This file. Because I haven't put everything in a main yet. There we go. Everything is in the main. Okay. And that runs. Kick-ass. That took us nearly to 50 minutes. So we have a bit of an extra time. We can cut that out. Pretty happy with that. Another thing that probably shouldn't take too long that I was thinking of was like just testing, you know, if we, because right now we're running Bangalang from the Bangalang folder, but in practice you would run it from different folder. Like normally you would, your project would not be in the Bangalang folder where the compiler is. So we just need to make sure that that works. I'm pretty sure it will not work. So if I, yeah, so at the moment, can I make this bigger? Yeah. At the moment we're in the Bangalang examples folder, which is good. So if we went back to Bangalang, we should be able to do We don't have bang C here. Actually, I think bang C should be at the root. Anyway, we'll just, if we say bin / bang C, yeah, okay. So we're running bang C here, and we want to run examples / playground. And it runs. And it runs very fast. I guess most of the time we're first building the compiler and then running the compiler. And I guess building the compiler is what's taking most of the time, because that's like, yeah, pretty instant. Yeah, so that works. If we cd into examples, and we go like this, and now it would just be the playground module, because it's relative to where we are. Failed to read global's module file. Yeah, I have a feeling that there's going to be some paths that are wrong. So at the moment, I think all the paths that I do are relative to where Bangalang is getting executed. So sometimes they should be relative to the current working directory, and sometimes they should be relative to where the executable is. It's just two different things. So right now, failed to read global's module file, that's in the main. Let's close a bunch of these. Failed to read global modules file. So yeah, it's got a relative path here. So this is relative to the current working directory, which is examples, but standard lib is not in examples. And I believe to get the directory of the executable, if we go to statements, I think we have it in here. Yeah, this. So os args0 is the path to the executable, to bang C. And I do think that I want bang C to be in the Bangalang directory, not in bin, in Bangalang. I think. Is that? Yeah. Yeah, let's do that. So it should be right in the root here. Why does it get built to somewhere else? Out path Bangalang C bin. Okay, we'll just cut this off. We should do that to the other ones as well. Health check. Apply. Now we run the playground from here. We probably, when we run it, I know we get library core not found. So again, it's, well, I guess now it's using this library thing. It doesn't need to go up as many directories anymore. This dir is pretty much like going up a directory. So because this is including /bang C, we at least need to take that off. And then we can go /standard lib, which is right here. Okay, so that's working there, and now we have bang C here. So we take bang C out of there. So now when we run this guy, we shouldn't be looking in bin anymore. So it still says failed to read global's module file. Where is that? That's here. Okay, so this path we need to do something similar to this. That's what I was trying to get at. I actually prefer a print if these days. So if we go strings a print f, It's just a little bit more compact. Well, no, it's format.aprintf. Then I can go %s /standardlib, and that is my variable. So that should get us the full path. So that's the path to the Bangalang folder. And then we're going /standardlib. Yeah, so that's good. We need the file path import. So that should correct that. That one still works. And when we run from here, failed to open out path. Okay, so we got past that one. The out path. Where do we define the out path? Here's out path. I think it's here, so it's just bin /. So now that we're in the examples folder, it should be examples bin. Maybe it's because the directory doesn't exist. New directory bin. Yeah. Yeah, so now I've made the output files here. It would be nice if they didn't have to exist. I think there is a os.make directory out path. Is that right? Because is that going to make let's try that. Failed to open out path. So if I run it here first, that works. And we didn't get any crazy extra directories, it looks like. Unless I need to like reload. So bin input, that would be bin playground, I guess. I don't think that's quite right, because we don't really want a playground folder. But I'm kind of surprised that it's like not, it seems to be not making it. Failed to open out file. And where is failed to open out file? Here. So yes, out path. Maybe I will, is it always still format dot print line out path. Bin examples playground. Bin playground. So within here, it should have made a directory. It doesn't need to be like ./ or something. Ah. Oh yeah, that one worked before. Bin examples. I'm kind of surprised it doesn't make. Okay, dot, but that still failed. Oh, should we do the file path thing? File path dot dir to cut off that last one. Does that help? There we go. Okay, that's better. That's actually what I wanted. So examples bin. So that ran in a different folder. Okay, I think that resolves that. I think it would be nice, like normally, if I'm just doing my own project and I would run it, and I go to bin, I would be like, what's all this? Like, that's no use to me, that stuff. This is useful. This stuff is not. It's only, like, the ASM is useful for when I'm developing the language and I want to debug the assembly. But for an end user, it's not useful. And the .o is really not useful. So I think I want to, so I can cross that off. But I think intermediaries and out compiler params. So I also want to be able to tweak where it goes. At the moment, it's hard-coded to go to bin. But you should be able to specify the out and whether to keep intermediaries or not, which would default to false. Yeah, I think those two, I won't do those right now, because I think that's a bit of a revamp of the way we do, we handle the parameters that get passed to the compiler, because at the moment it's very basic. But yeah, I think that's enough. We crossed off 2 and added 1. Progress, slow progress. But yeah, let's knock out this list and then get on to a new project. All right. Thanks for stopping by. Have a good one. Ciao for now.